Hello student, I hope you're doing very fine. In this video we are looking at the implicit differentiation algorithm, and in other words, if we are first to understand the meaning of an implicit function, an implicit function is one where the y is not a direct function of x, where y is not a direct function of x. For example, I can have, maybe if I have a function like xy is equal to a 10, or maybe xyz is equal to a 20, or x maybe y squared plus 7x is equal to maybe 2. These are implicit functions because y is not directly a function of x. So if we were to take an example, so we have a question that needs us to implicitly differentiate the function given to us. We have that given that xy is equal to 12, find the equation of the tangent on the curve at 3, 4. On the curve at 3, 4. It is a simple one, but then we need to understand how do we differentiate a function implicitly. So I have, maybe as part of our solution, I have there that xy is equal to 12. X and y, they are products, so I differentiate by product rule, whereby we say that if I have the d with respect to x of two functions that we are multiplying, we're going to have u, the d of v with respect to x, plus keeping v constant, give me the differentiation of u with respect to x, the same thing that we apply. We're going to differentiate everything throughout. So I have here, I'm going to keep x constant. If I keep x constant, I differentiate y with respect to x, I get dy, dx. Then plus keeping y constant, I have dx, I'm differentiating now x with respect to x, which is a 1, will equal to the differentiation excuse me, the differentiation of 12, which is 0 because it is a constant. So I have x dy dx, x dy dx plus a y times 1 is equal to 0. This is times 1, such that my dy dx dx will equal to a negative y. Then I divide through by x, so it is negative y divided by x. And we said, remember that now this one is my gradient function. This is what we call the gradient function, such that at the point given to me 3, 4, my gradient dy dx, my gradient dy dx is equal to, I put in here, so it's negative 4 out of 3. Then I can use either the general equation of a line, y is equal to mx plus c, or I use the gradient formula. So I have change in y minus 4 divided by a change in x minus 3 will equal to the gradient, which is negative 4 out of 3. I can now cross multiply, so that I'm going to have if I cross multiply, I'm going to have here a 3, I'm going to have here 3y, a 3y minus a 12 will equal to this guy times that. I have here 4x excuse me, a 4x. I'm going to have, this is negative, so negative 4x, then this one here, this guy, and this one, this times that. I see, is it a negative, what, a negative or a positive? See, this is a positive 12, such that if we put it maybe in the form y is equal to mx plus c, I take this k the other side to give me 24, divide through by 3, that my y will equal to negative 4 out of 3 x, then plus, it would be plus 24, but when I divide it by 3, then it is plus 8. So this is going to be the equation of the tangent to the curve. Remember, they could have said the equation of the normal to the curve, then we would first get the gradient, the m, which is the gradient, then use that m1 times m2 is equal to negative 1 to get the gradient of the normal, and then every other thing now would follow the same protocol. We'll just change this guy here by replacing it with the gradient of the normal line or the perpendicular line. So our next question is that find the gradient of the curve x² plus 2xy minus 2y² plus plus an x is equal to a 2 at the point negative 4, 1. At the point negative 1, it is also a simple one, such that now if I say as part of our solution, we have there that x squared plus a 2xy minus a 2y squared plus an x is equal to a 2. So we differentiate the whole function implicitly or implicitly, such that now I differentiate each term. You're there, I differentiate each term. So if I differentiate this guy with respect to x, I'm going to be having here a 2x, then plus, now here product rule. This guy is a product of two terms, so I can first keep x constant. I get 2x dy dx plus, now I keep y constant, I differentiate x, I see here a 2y, then dx which is 1, dx which is 1, then minus now. So how do I differentiate this guy? I lower down the power such that I get 4, then y, then dy dx. That is how we differentiate this guy. If it was like y cubed, I'm differentiating it with respect to x, it will be 3, lower down the power, then reduce it, then dy dx, it would be such. So here I lowered down the power to multiply it here, getting a 4, y, I reduce the power by 1, then dy dx, then plus the differentiation of this burden. When I differentiate x, I get a 1, will equal, when I differentiate 2, I get a 0. Excuse me. So that this one and this one, I can factorize, I can bring these two guys together, I factorize out the dy. In other words, I have here 2x minus 4y. This is dy dx, dy dx. I can take these guys the other side. I can have there a negative 2x minus a 2y minus 1, then I divide through by 2x minus 4, so that my dy dx will equal to negative 2x minus 2y minus 1 divided by a 2x minus 4y, such that this is the gradient function, but the question wants the gradient, such that at the point at negative 4, 1, so my dy dx, I'm going to have a dy dx that is equal to, a substituting, this is going to be negative 2 multiplied by negative 4, then minus a 2 minus 1, then I'm dividing it by, I have here 2x, which is going to be 2 times negative 4, then this is minus a 4 times 1, such that I have this and this is going to be an 8 minus 3 divided by a negative 8 minus 4, which I say as negative 5. I see this guy as a negative 5 out of 12 as my gradient. Therefore, the gradient of the curve is negative 5 out of 12. As simple as that. Hope you guys have tried to follow. But we have said subscribe to our channel, then hit the notification button, like our videos, and then tell a friend, such that we pass together and succeed together. Otherwise, the best regards. Watch our next video.